Okay, so let us find uh, some data set which is known as the vector data, or also it is known as the shapefile. So let me write here. Uh, okay, so this is known as the vector data, right? Vector data. So vector data consists of points, as we have discussed before. Then we have the line, and next is the polygon. So these all are a part of known as GIS, Geographical Information Systems. Okay, so there are numerous sites where actually we can find this data. Let us. One of such sites is known as the Diva GIS, DIVA, Diva GIS. Okay, so here you can go to free spatial data. Okay, so here you see free spatial data, then country level data. You can click on here, and then all the country, they are alphabetically arranged here. Let us search for India. India, and let us find the boundaries or administrative areas. We click OK. Okay, so we can download it here. Right. Okay, so this data is now downloaded. So this is a zip file. Okay, so you will need an application like WinZip or WinRAR to open this file. Right click and you say extract. Okay, so this is our spatial data. These are the save file. This is also known as a shapefile. SHAPEFILE, shapefile. Okay, I am using my ArcGIS application to open the shapefile. So here I will go to our catalog. From the next class, I will expect you to install QGIS, and then together we can work. Okay, go there. I'm going to that particular folder, and wait a minute. Okay, so these are the shape files. As you can see, India admin 0, India admin 1, India admin 2. So from here I will just pick up one of like this and then drag and drop. Just a moment. Yes, so here this is the available free open source data for India. This map is a little bit controversial, as you can see on the top on the north, but since we don't have other sources of data right now, I will just proceed with this map. Okay. Then there is another data, which is the states of India, which are being shown here. So you can see the states, okay, Assam, Arunachal Pradesh, Nagaland, Manipur, Tripura, Meghalaya, Sikkim. Okay, so next level data is actually the district level data. So here all the districts of India are there, including Andaman and Nicobar Islands. Can you see here? Okay, so yesterday also we have downloaded another data set, which is this. Just a moment. This one. So this was our, so I drag it to the top, and there you can see it here. From Impal. So this is the digital elevation model of one scene from the state of Impal that covers the Loktak Lake. Okay. Okay, so anyone from Impal here today? We can give it a shape. Okay, so higher values of elevation, these are shown in dark red color, and lower values of elevation, these are in blue shades. Okay. As you zoom in farther and farther, you will see the individual pixels. Okay. So here you see the pixel value 1002, which is actually the height of this particular area. Okay, so there is another height. You click here, then you see 1050. This is the height of this pixel. So now coming to what is the application of this data? Can you tell me what is the application of this data? Application of DEM. Okay. What may be the application of a DEM or digital elevation model? It can have applications during the disaster time, as well as this can have an application during a normal period. This is a satellite data. Okay, so since you are students of disaster management trying to learn remote sensing, I ask what is the application, site and application of this DEM? Who can tell? We have discussed this thing before, even during the class. Yeah. First of all, can you switch on your video today? I don't want to speak in front of a wall. You don't respond after repeated questions, neither you show up. I don't really want to waste my time like this. This is a basic minimum courtesy. When a teacher asks something, at least you should respond. Otherwise, what's the point? I really don't understand. So, who can come forward and just answer? From the beginning, I have told that this is not something about right and wrong. This is about your attitude. Yeah? Why I don't see anyone there? Are you actually listening? Whatever I'm saying?
Yes, sir. Yes, sir.
Yeah. So, can you just, first of all, is it anything that you have not understood really? That what I am asking repeatedly. Because this whole subject is about satellite images and then its application. Huh? I haven't really forced anyone to really take up this subject. But if you really come up with this kind of an attitude, then there is no point actually you studying this subject at all. Do you have a laptop by now, all of you? If you don't really have a laptop, then how will you practice these things? And you see, if these are some of the practical subjects. These are practical subjects. These are very much relevant practical subjects. So I'm trying my best, staying online, but if you don't come forward with the tools that are needed, hmm, how can I actually help you? Okay, so now tell me, This is an SRTM image, right? SRTM stands for Shuttle Radar Topographic Mission. As I said yesterday, discussed this yesterday. This is having the information of the undulations on the Earth, the tops, the bottoms, the ups and downs near Loktak or some place in Manipur. So if you get this kind of a data, what can you really use this data for? That is the question. These are hills, these are depressions. So if I give you this kind of a data, or if you get hold of such kind of a data, where do you think you can use this data? That is the question. Hmm? Do you think this data has really any application, or we really need this kind of data? Asimnath. Yes. Oh, even if I ask you by the name, you fail to really answer. Asimnath, are you here? You're not there? Asimnath? What kind of an attitude is this? You can write your message in the chat. I am asking you a question. What is the use of this DEM or digital elevation model? Speak up. This is about a master's class. That's what I'm saying from the beginning. This is not about right or wrong.
Hello, sir.
Yeah.
Maybe, sir, this DEM is, I think, used for geological analysis
How can we use DEM for
for hazard
geological? Yeah. How can we use it for geological analysis? So
uh,
geological.
for money
Mm,
or sir for hazard monitoring.
for hazard monitoring. Okay. So at least she has given an answer. So can you add it to it? What are maybe the other applications of a DEM? First of all, this DEM is different from a normal satellite image, as I have told you yesterday. Extracting terrain parameters for geomorphology, modeling water flow, hydrology, mass movement. Yeah. So if you can extract this thing for geomorphology, so how can we use it for disaster monitoring? What is geomorphology? Hmm. Okay, tell me terrain parameter. What may be one terrain parameter? Terrain parameter. terrain parameter. So there is one word she has given it here. Terrain parameter. Terrain parameter. What is a terrain parameter? Let us discuss it today. Okay, rather than terrain parameter. Parameter. What can we tell about terrain parameters? So what may be the terrain parameters? Come on. What do you understand by terrain? Terrain. This is for everyone, okay, this question. Asif,
Sir,
what comes to your mind when you hear the word terrain?
like mountains or hills,
Yeah,
like
yeah. Okay, so in general, it is the topography or the terrain. That means whatever is there on the surface of the earth. Sometimes on the top of the surface of the earth you have the barren land, and sometimes you may have trees, you may have buildings, you may have other features. So these all are included when I talk about the word terrain. Okay. So digital elevation model sometimes is also known as digital terrain model. So there is a slight difference between the digital elevation and digital terrain. So terrain includes all the parameters, including the top of the buildings, the trees, and everything. But whenever you talk about the elevation, normally, whenever we talk about the digital elevation model, it includes everything, including the house tops, the rooftops, the trees. So if you have a tree that is 3 meter tall, whatever is the top profile of the tree will be called as digital elevation. But whenever we talk about the terrain, we have to minus these tree tops, the building heights, and then only we will include the art surface. So if you get to know about the surface of the art, like what is the height from the mean sea level, so this is one of the properties of the terrain. We can talk about many other properties, like what is the slope. So now if I come to the word slope, this is one derived property of a terrain. Okay, so as Priyanka has given it here. Okay, terrain parameter. So if I talk about the terrain parameter, one of the parameters is the height. So since this is one digital elevation model, so I'm giving you an example in front of you. Just see this. So these heights for individual pixels are one of the properties. So another properties may be the slope. So what is the slope? See, you have to know about these things before we really want to analyze disaster situation. One is the height, H-E-I-G-H-T, height. That means, suppose this is your elevation, okay? So here you have a house like this, and then I want to know the elevation of my house from a certain datum. This is known as the datum, D-A-T-U-M, or the reference. Normally, this is also known as the MSL, or the mean sea level. So from the mean sea level, I know that this height is supposed 2049 meter. Okay, this is known as H, or the height of this particular area from the mean sea level. So this is the height of that particular pixel. or particular 30 meter by 30 meter area of this building, where the building is situated from the mean sea level. So this is one of the properties. So one of the properties is the height, H-E-I-G-H-T, height. Another property, as I said, it may be the slope. So what is the slope? What do you understand by the word slope? Huh? Is it too difficult for you? First of all, please tell me. Have you heard the word slope? Because maybe this is my first time also I'm taking a class to a majority of the humanity students. What do you understand by the word slope? Slope? Have you heard this word before? First tell me. Yeah? Zuri Sunwal, you are here? Let us make it an interactive session. Why are you shying away from it? There are so many things I also don't know. Most of the things I don't know. So you don't have to really feel shy about the things you don't know. I am asking you a question. Have you heard about the word slope? Slope. Hmm? Who can tell from the group?
Sir, slope is the ratio of the vertical
Okay,
point
Race.
to distinct points.
Okay, so this is a scientific definition of the slope. But if I say what is the physical meaning of slope, you can say it like delta x by delta y. Okay, but what is the physical meaning if I say slope? Slope? Look at this box. Look at this surface of the box. If the box is like this, it has a slope of 0 degree. If I raise the surface like this, I am increasing the slope. I am increasing the slope. I'm increasing the slope. At one point of time, anything that you put here will just slide away. So this angle that it makes with the vertical plane, this is the slope. So sometimes if you want to climb a hill, you will notice that some faces they have higher slopes. Some faces their slopes are less. So if the slope is higher or steep, we say it is difficult to climb. If the slope is not very steep, it's easy for us to climb. So slope is one of the properties of the terrain or the topography. Is it? So at this point, if I say what is the slope of this, so I will say, okay, let us take a horizontal line and then find out this angle, theta. So if the angle is 90 degree, the slope is really steep. If the angle is 0 degree, that means we don't have a slope. For this particular plane, this is a flat surface. So the slope is 0 degree. It doesn't really have a slope. But look at this surface. So this surface, it does have a slope with the horizontal plane. So this is theta. So this may be 30 degree. So sometimes the slope is bigger, sometimes the slope is smaller. So depending on that, the terrain will behave differently. Okay, tell me, is it difficult to understand? Dharmananda, is it difficult to understand?
No, sir.
Okay, good. So that's why I say So we can derive this information from the satellite image. That is the next thing that I'm going to show. Okay? Stay with me. So this is my satellite image. This is, first I have to reproject this image. So how I do it, I am not asking you to do it right now, but I will explain how you can extract slope from this satellite image. Okay, first of all, we have to reproject. P-R-O-J. Just a moment. Project raster data. So what is reprojection? I will explain it maybe in the next project when we are going to do. Actually, as I said in the beginning, this data set is in a three-dimensional coordinate reference system. That means all the measurements of the latitudes or longitudes. So we will have to first project this data onto a two-dimensional surface. Okay. Depending on the UTM zone, I am going to reproject it. So this is known as reprojection of the raster data. You just see today. Okay. No need to do it by yourself. Just remember the step. So this data set we'll have to first reproject. Let me. So I am using some tools using this software. This one. You need to know the application areas, and then you need to also know what is the background, how we are going to use it. Then in disaster management, it would be easy for you to interpret the data when you get the raw data. Just a moment. It's taking some time. Okay, so you see input coordinate system optional. So this is WGS 1984, which is a three-dimensional coordinate reference system. And then we have to select the output coordinate reference system. So remember just this thing in mind, that right now I am reprojecting this data into a two-dimensional surface. So as I said, for India and for Northeast India, we have the coordinate, we have the UTM zone of 46 north. So that's why I'm picking up this. Okay. Just you see, this is going to be fun. I am trying to extract various parameters of the terrain. Okay, but before that, I'm trying to project the 3D data into a two-dimensional surface. Okay, just wait a moment, 5 minutes. Now the software is working on it, and then ultimately every grid or every pixel will be reprojected into this surface, a flat surface. After that, we can extract the terrain parameters. Then we'll discuss taking on this image, what further we can do with this image. Okay. Oh, this is going to end anyway. So let me find the answer. Terrain parameters for geomorphology. Okay, what is geomorphology? Do you have some idea? Study of landforms. Okay, so later is they've written it. Study of landform is geomorphology. Parameters of land surface from that can be measured on the real surface is computed. Okay, so parameters of land surface form that can be measured on the real surfaces computed from them. Okay, tell me in simple term, what may be another application of a dam? These are the Google searched words, which I don't really want. What may be the one simple example? You imagine a situation during the disaster. So what can be a disaster, natural disaster? Okay, you see here, this is the Loktak Lake, right? And then this lake is fed by some river, not only one river, maybe one or two rivers. So if you want to really build a dam, and then you have built a dam here, this may be one of the streams, these dark areas, and then suddenly during the time of a disaster, if the dam breaks, so where the water is likely to flow, in order to calculate that, we will need this kind of a data or digital elevation model. This is one of the application areas, mostly during the disaster. Okay, so this is our projected DEM. Okay, this is our projected DEM. How do I know this is a projected DEM? So I right click here, I'll go to the property, and then if I go to source and then I want to read about the metadata, I will see that the coordinate system is WG is 1984, zone is 46 north. So this means this data is already projected to 46th north zone. Okay. Now, as I talked about the slope, let us find the slope. SLOPE, slope. I am using this input projected data as my data source. Then output measurement, you see now it is in degrees. That means how much degree that particular pixel does have. Okay, just everything remain like that. Okay, you see it now. So now each of the pixels, they are in different colors, and all these colors actually represent now the slope in degree. So if I put this information and click somewhere here, I will get this particular pixel suppose has a slope of 26.71 degree. That means this particular pixel is not flat. This pixel is either tilted this way, or this pixel may be tilted that way, or this way, either to the north or to the south, or to the east or to